So you were right. If I plug in g of 1, I get out absolute value of 1 plus 2 minus 5. That ends up being negative 2. And if you look at your graph, 1 goes down to negative 2. Okay, so for the next two, it is giving us what g of x equals and wanting us to find the y or the y's. So for these, we would take that x plus 2 and the absolute value minus 5 and set it equal to negative 4. Now to solve absolute value problems, it may have been a minute since you've done this, we first get the absolute value by itself. We isolate it, so we're going to add the 5 to both sides. And then, does anybody remember, what do you do when you're trying to solve for an absolute value? It's okay if you don't. Okay, you end up with two things you can get. You can either get what was inside the absolute value to actually be that positive 1, or what was inside that absolute value could equal negative 1. Because when you take the absolute value of it, it would have changed it to this positive 1 right here. So when you're trying to get rid of the absolute value to solve, you have to set up two equations. One, just drop the absolute value. The second one, drop the absolute value, but change the sign of what it's equal to. And then you just solve both of these. Then we have x equals negative 1 and x equals negative 3. And we're going to check these again on our graph and make sure we have those points. X is negative 1, y is negative 4. So negative 1, negative 4. And the other one, negative 3, negative 4. Sure enough, they're both there. The one next to it is the same. So try that one. See if you can work that one out. And g of x is equal to 5. Kendrick, how do we set this problem up? Absolute value, yep, x plus 2, good.
Minus 5 equals 5.
Good. Then what, Jose? Yep. Cameron, then what?
We do x plus 2 equals 10, and then x plus 2 equals negative 10.
Good. So then what are our answers, Isella?
8 and negative 12.
Good. I don't think my graph's going to go that far. Alright. Okay, this one has a square root in it. We'll do h of -1 together. So h of -1 just means that we replace x with -1. Make sure what's under the square root, that should be under the square root, stays under the square root. You get -2 times square root of 5 plus 3, and that's fine. Algebraically, I can't simplify that. If I wanted to get a decimal answer, it's like 1.472. You could check it out on the graph, but no need. I want you to find h of 10. What'd you get, Taylor?
-5.
That's right. You plug in 10, you get -2 times the square root of 10 plus 6 plus 3. So that's square root of 16. Square root of 16 is 4. So that's -8. Oops. There we go. -8 plus 3, which is indeed -5. And I can look, well, no, I really can't because it doesn't go all the way up to 10, but I would have the ordered pair -5, positive. Oh, wait a minute. No, it'd be 10, -5. That would be like way over here somewhere if I was looking at that graph. A question? We good? Are we good? Okay. Okay, on the next two, this time, what do I do, Jenna? How would I solve h of x equals 1? Yeah. So I'd take that square root, so it's -2 square root of x plus 6, and then plus 3. Is that equal to 1? And I'm going to do the same thing over here. And it's going to equal -3. You go ahead and solve those two.